this is section 9.6. We're going to talk about inverse trigonometry. So inverse always means the opposite. Like when we talk about inverse operations, we're talking about what undoes something in a problem. So the inverse operation to addition is subtraction, and the inverse operation to multiplication is division. Each of our trig ratios has an inverse. If you know two sides of a right triangle, you can find the measure of the angle by using the inverse trigonometric ratio. So they're still the same ratios, sine, cosine, tangent, using SOHCAHTOA, but now instead of using the buttons on the calculator that just said SIN, COS, and TAN, we're going to use the ones that look like they're being raised to a power of -1. And we call those inverse sine, inverse cosine, and inverse tangent. So for example 1a, we want to solve for x. So x is the angle we're using. So that's the angle I'm going to use to label the three sides as O, A, and H. We know 24 is our hypotenuse. And if this is my angle, opposite it is the 15, and this side would have been adjacent. I'm not going to label it right now because I don't know that side, and it's not going to help me solve my problem. Knowing that we're using SOHCAHTOA, I have the O and I have the H, and the O and the H are right here with S. So that tells me I'm going to be setting up a sine problem. So for these, instead of saying sine of the angle equals the O over the H, we're going to say the angle equals the inverse sine of the O over the H, so the 15 over the 24. So we're going to use our calculators to find this. So I'll show you on my graphing calculator. I'm going to make sure it's in degree mode. This is right now in radian mode. So I'm going to hit second. Oh, I'm going to hit mode. I'm going to go down to degree. And we're going to enter. So now we are in degree mode. And I want to find the inverse sine. So I'm going to hit second, sine, and now I have the sign with the -1, and let's just make sure I'm doing 15 over 24, so 15 divided by 24, enter. So I get 38.7. So x equals 38.7. And it's an angle, so if we want to say degrees, we can. And that's all there is to this problem. All right, example 1b, we'll do a few together. Here's my angle. This side would be my hypotenuse. That would be opposite it, but I don't have an O in that picture, and this then would be A. So using the combination of A and H, that's cosine. So x will equal the inverse cosine of A over H, so that's 8 over 11. So we're going to hit second or shift cosine, 8 divided by 11, and we get x is 43.3 degrees. If you have the TI-36 Pro, you would hit the sine, cosine, or tangent button twice to get to our inverses. If you have the TI-34, that's the blue and white calculator, and you have to do the drop-down menu to find sine, cosine, and tangent, you're going to do the same thing, but we're going to keep scrolling past tangent until we see the inverse functions. All right, example 1c. Here's my angle. We don't have the hypotenuse this time, so I won't label my H, but 20 would be opposite the angle, and 37 would then be adjacent to the angle. So the combination of O and A would be tangent. So x will equal the inverse tangent of O over A, so 20 over 37. So on our calculator, we would get x is 28.39, so that's going to be 28.4. All right, one more together. Example 1D. The hypotenuse is 23. Opposite the x would have been this side, which we don't have a number for, and 18 is then adjacent. So this is once again cosine. AH is cosine. So x will equal the inverse cosine of a over h, so 18 over 23. And I get 38.49999 stuff, so x will equal 38.5. So here are some for you to try. You can pause. Answers are posted on Google Classroom. And then, of course, we're going to have some word problems. So, for example, 2A. Jaden is flying a kite and lets off 275 feet of string. If the kite is 150 feet above the ground, and assuming the string is straight, what angle does the string make with the ground? So we have a string leading up to a kite that's 275 feet. We have the kite that's in the air is 150 feet above the ground. And we would like to know the angle formed by the string and the ground. So that is where our angle would go. And now this becomes just like one of the first four that we had done. We have our O and our H. That combination means sine. So x will equal the inverse sine of 150 over 275. So that would give me about 33.1 degree angle. Example 2B. A dog is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet up the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat? So in our right triangle, we have a dog looking up at a cat. So the dog is 5 feet from the tree, and the cat is 16 feet up the tree. And we're looking for the angle of elevation, which is always on the bottom horizontal line. We have O and A. This combination tells me I'm going to use tangent. So x will equal the inverse tangent of 16 over 5. So my angle would be 72.6 degrees. One more example together. A fireman leaned a 36-foot ladder against a building. If he placed the ladder 7 feet from the base of the building, what angle is formed between the ladder and the ground? So in our problem, we have a ladder leaning against a building. The ladder is the part that's leaning, so that part would be 36 feet. He places it 7 feet from the building. So if this is the building, 7 feet away would represent the bottom. And we are once again looking for the angle formed by the ladder and the ground, which is our angle of elevation. We have A and H. That combination is cosine. So x will equal the inverse cosine of 7 over 36. So x would equal 78.8 degrees in this problem. So there's one here for you to try. You can pause. Answers are posted on Google Classroom. Our last example is actually a challenge. We're going to find the measure of angle W. So in this triangle, if I want angle W, I know the adjacent side right now, but I don't know either other side. And I do need to know two sides to do this. What I can do is I can use this side, which is my opposite, once I find it. To find it, I'm going to use the other right triangle. And in the other right triangle, we had this side is 15, this angle is 25 degrees, and we need the side xz. So I'm going to make it another variable. We're going to call it y for right now. So we can solve this problem using our original trigonometry. We have an angle. We have O and H to use. That's going to be a sine problem. So sine of 25 will equal O over H, so that's 15 over y. With my number being in the numerator, we're going to use division. So y will equal 15 divided by the sine of 25. So y is about 35.5. So now this side of the triangle that I called my opposite is 35.5. And to find the angle, we'll use the inverse trig. So we knew the angle in this part, we used the regular trig. We're looking for the angle in this one, we're going to use the inverse. So O and A is tangent, so inverse tangent of 35.5 over 22. And I get, I'll call it angle W because that's what they asked us for. The measure of angle W is 58.2 degrees. And that is the end of day 1 of section 9.6.